Let's talk about, I don't know, let's talk about making wine. Let's talk about the direct materials for making wine. Say we have two main processes in the winemaking business. You have the making, what's winemaking? I mean, it's like in beer it's brewing. What would it be in winemaking? What's that? Fermentation. Let's just call it the making process and the bottling process. What's that? Growing? Oh, for the grapes. We're going to start our thought process after the grapes have been harvested. Let's say you outsource the growing. That's not a part of your business. Let's talk about direct materials. Where did direct materials come into play in the winemaking business? The fruit. But like, think of this as a timeline. Where on the timeline do the products, did you get your direct materials? You get your grapes here, right? So you get some direct materials there. Any other direct materials? You need some bottles and corks and stuff, right? So you have some direct materials there. Where else would you have, if any, direct materials? The barrels to age it, but those are interesting. Those are probably overhead, right? Because you reuse the barrels over and over again. That's part of the. Yeah, I would think. Yeah, some don't even use barrels anymore. They use metal vats. But the barrels, let's think about that. I don't think of the barrels necessarily as direct materials. Anything else? So at the end of bottling, they add some packaging. I might as well be more specific. These are bottles. And this is the grapes. Anything else? Yeah, somewhere back here, right? Sugar and preservatives. Unfortunately, not the good wines. Sugar and preservatives there. Anything else? That's what I have in my mind. But there might be some other things. I don't know the industry that well. So direct materials happen in a few distinct points in the process, right? Let's talk about direct labor. How is direct labor approximately spent in this process? Yeah, we're starting with having the grapes here. We're assuming that they outsourced. It's not. But yes, you would have people picking the grapes and all that stuff, stomping on the grapes. It's more continuous. Direct labor is definitely more continuous. So, at least in this part. And would you say it's front-loaded, back-loaded, kind of equal throughout? Loaded on the edges, so it's bigger here. Then you let it just sit. Maybe you have somebody who's tasting it to make sure it's. How about on bottling? Again, it's continuous. Good. And is it bigger or smaller than here? What do you think in terms of the amount of direct labor? smaller, right? It's just somebody who's making sure the bottles are staying on the line okay. So it's continuous. And what about overhead? You know, the person who has to make sure that the wine cellar is clean, the cost of electricity in the wine cellar, if there is any. What's that? It might be, but it's probably higher than direct labor. But it's continuous also, right? And I'm going to guess it's continuous all the way through at a pretty constant pace. So this, in essence, is a good microcosm or good picture of how a process flow business works. So we're moving from job flow to process flow. And we're jumping from chapter 4 to chapter 6. So I think it's an appropriate way to go. A process flow business will add direct materials at distinct moments in the process. Will have direct labor and overhead applied continuously, but not necessarily at the same rates, but possibly at the same rates, and not necessarily at the same rates across the process. It might be front-loaded, back-loaded. You know, you just because you're halfway done with your winemaking doesn't mean you're halfway done with your direct labor costs. And you could have said the same thing about beer making, or lots of different types of process businesses. Okay, process costing. For those of you who like math, strap in. I mean, it's not hard math, but it's math nonetheless. Well, again, the characteristics of firms that use process costing. 5 steps in performing process costing. How to apply process costing when you were the firm with more than one department, as our winemaker did. It had the winemaking and then the bottling departments. What's unique about that? And how to prepare journal entries. I'm not sure we're doing those journal entries. Maybe. Okay, so let's just review where we are. We said there were 3 questions you need answered in the costing environment. We've talked about job costing. We've talked about actual and normal costing. We've talked a little bit about volume-based overhead application. That's what we were just doing for the job environment. Now we'll talk about process costing. Leaving out standard costing, because it's unique to later on in the semester if we get to it. So process costing is a product costing system that accumulates costs according to processes or departments, winemaking and bottling. And since it's a process, you really can't assign the cost to a specific product. there's not this gram of wine that you can say this gram of wine costs all these things, or this ounce of wine, or whatever. So you need to accumulate costs and then spread them over your output. So it's a different model than job costing. Prime users are companies that have homogeneous products that pass through a series of similar processes or departments, or they engage in mass production of a few products. You've seen this list before. Canneries are kind of like beverage manufacturers. So clearly beverage manufacturers would be in this category. Oil refineries and chemical companies would be in this category. If you had only one production department, you'd somehow get your costs into work in process, and you pass them on through to cost of goods sold. You need to think about and focus on the unit cost of performing a process in a given period, say monthly. And the challenge you have, because a process doesn't just stop at the end of each month and then start the next month. So one of the key challenge you have in process costing is factoring in costs that have been accumulated in a process from the previous period, and what do you do with them in the current period? And so this is the challenge that we'll spend most of our time today talking about. And the key to solving that challenge is working with something called equivalent units. And they are just what you think they are. If you're halfway through something and you have 2 units of that, that's one equivalent unit, 2 times 0.5. So you figure out how far you are along in a process, and you can then start to calculate things according to equivalent units. And then once you know your equivalent units, you can then figure out your cost per unit. So that's the cost incurred divided by the total cost incurred divided by the number of equivalent units produced. And there are 2 ways to do it: FIFO and weighted average. FIFO is a bit more complicated to calculate. We'll go through it, but also a little bit more precise. But so, as in everything, sometimes weighted average is just fine. In a process environment, we often use conversion costs, meaning you don't differentiate the direct labor and overhead. You lump them together into conversion costs. The example we're going through in class does not lump them together, but quite often you will lump them together into a single category for calculation purposes. Because as we showed with our winemaking, you would incur these conversion costs uniformly throughout the cycle, and so you could treat them together. I implied, just to show that it's possible otherwise, that labor may be incurred at a different rate than overhead, in which case you would not lump them together. If you front load labor in winemaking because it's more important for people to be involved early on and then you don't care about it later on, then you can't treat it like conversion costs because the overhead's probably going to be even all the way through. So you have to look at the business and decide whether you can treat them as a single entity or separate out labor from overhead. And as we saw, direct materials in a process environment are added at discrete points in time. For many businesses, direct labor is, or direct materials, excuse me, is all included at the very beginning of the process. If it wasn't for the fact that wines add phosphates and sugar maybe and other things towards the end, they didn't do that, you could almost say that winemaking would be all, you put all the good stuff in at the beginning and let nature do the rest. If for some reason direct materials go in continuously, and it's possible, there's some kind of a drip process, you drip in direct materials all the way through the process, can't think of one off the top of my head, then you would treat it in this kind of the same model we're going to talk about for conversion costs. Otherwise, it's more direct. And as I said, quite often it can be all at the beginning of a process or at multiple points along a process. Okay, weighted average versus FIFO. At the beginning of each period, you have beginning work in process in a process environment, which is the previous period's, whatever's left from the previous period, the wine that's still fermenting. In weighted average method, it includes the costs for that work in process inventory as you're figuring out your current costs. It doesn't subtract them out. So it averages from one period to the next, from last month and this month, you get an averaged answer, which just smooths things out, which might be okay. Might be okay because your processes are approximately the same from month to month. Winemaking may be a good example of that. But if you're a business that relies on fuel as a direct material, oil prices fluctuate dramatically, it's not as good to have this weighted average because you're not really getting the costs from one period to the next. The FIFO method includes only costs incurred and work performed this period. So it has to subtract out the costs of that initial work in process inventory. So it more closely represents the true costs this period. It's not thinking about the cost that you brought in. And as I said, weighted average is going to smooth out cost differentials from period to period because of this averaging process, whereas FIFO is going to accentuate them. You really see your period to period costs better. Visually, this is what I just said. At the beginning of June, you had some product that was in process. This represents the remaining work needed to complete it. This represents the work that was already done to get it to its current state at the beginning of June. During June, you're going to start and finish some products. Also during June, you're going to start some product and leave it for the next period. I mean, this stuff is easy. You have to account for that. This is easy, and that's easy. You account for these in both weighted average and FIFO. The weighted average also includes this, whereas FIFO does not, and that's the primary difference. Yeah, I think I answered this earlier, but from the standpoint of cost control, why is FIFO superior to weighted average? it more accurately represents the cost. Absolutely. And I think, is it possible to monitor cost trends using weighted average? Yeah, but not as well. I think that's right. I think you can see the trends, but you're not really sure because you're not getting rid of it. Okay, you guys ready to strap in for some math? The way I'll do this, I got it. But you did it wrong. I know your name is short. We'll go. I'll explain what the steps are. We'll go through some very simple math. Then I'll take us through a more complicated problem, but I'm going to walk through it here. You may or may not get it. There are homework assignments, homework questions, where you get to work it. I suggest doing those homework assignments at your leisure so you really understand how you would do it. That's it. Okay, so the production cost report is what brings together the cost information in a process environment. And the 5 steps to produce this report. First, you need to account for all of your physical units, the units that you're selling. Think of wine, ounces of wine. You want to calculate your equivalent units. The numbers will be different for FIFO and weighted average. And we'll go through an example taking weighted average all the way through. And we'll go through the same example taking FIFO all the way through. You want to determine the total cost for each cost element. The cost elements being direct materials, direct labor, and overhead. Sometimes direct labor and overhead grouped together into conversion. And that will be different for FIFO and weighted average as well, because weighted average will include the starting inventory, and FIFO won't. Then based upon what you've calculated here in 1 to 3, you'll be able to compute your cost per equivalent unit for each cost element, for direct materials, direct labor, and overhead. And then you'll be able to allocate to work in process inventory, because you'll have your numbers available after step 4. Okay? Let's do a practice exercise, 2 exercises on step 1, accounting for the physical units. A little easy math you all can do at your desks, and just take a minute or 2 to answer these questions. How many of you are done? How many of you are lost? Thank you. Thank you for your honesty. Why the frown, Amanda? Hey, how many of you know who Coney is now? Almost everybody. 70 million hits in a week. What do I think about it? I think that if I were the filmmaker, and if I truly believed in my goal, which I'm going to say he does, because I have no reason to think he doesn't, he should be happy that people are talking about it. It's about publicity on the topic, right? And if there wasn't some controversy, there would be no publicity. So he should be happy to hear about that, because it serves his purpose. If I were him, that's how I would look at it. The cause seems just. I don't know enough about it. To me, it's the social media aspect of it and the movement towards perfect information. We'll never get to perfect information, but the movement towards perfect information and what that means in the long haul for lots of different topics, I find that to be the fascinating. Because I don't think he released. I think, didn't he just release the video recently? Right. He hit it. This one hit at the right time with the right note, I guess. I don't know the reason to that, but it's fascinating that, see if it reaches a just result and all that stuff. But it's fascinating what the possibilities are. How many short documentaries get 70 million people to watch them? I don't know if 70 million people watched it all the way through, but think about it. They deny that. I don't know the answer to that, and it might be because the cost of the video was high, in the first year. Yeah. Yeah, I don't know the answer to that. Okay. Somebody want to walk me through this, or should I walk you through it? What are some answers we got? Why don't we just do it this way? What are some answers we have? 5,200. What's that? Oh, I want to do number one first. 65,000. Anything else? So it was too easy, right? 65,000. It was meant to be easy. So you start with 80,000. You added 60,000. You subtracted 75,000, which leaves you with 65,000. Another way to look at it is everything started 80,000 plus 60,000 needs to equal everything at the end, either finished or moved on to the next period. So 65,000 plus 75,000 has to equal 80,000 plus 60,000. A couple ways to look at it. And so the answer to the second one Liz told us is 5,200. Same problem, different numbers. Okay, this all seems very easy. Let's do a practice calculating equivalent units in two ways. Step 2. So you start off with beginning inventory of 2,000 units. Completely, all of the direct materials has been already added. 50% of the conversion costs have been incurred for the production of this product. You've completed 44,000 units. Notice we don't care too much about started units and the true calculations. You need the started units sometime to calculate for completed units, etc. And at the end, you have 3,000 units still incomplete. And those 3,000 units are 100% completed for direct materials. In this case, all the direct materials are added right up front. And they're 70% complete for their conversion costs, meaning you're a good ways through those 3,000 units. I'd like you to calculate your equivalent units for direct materials and conversion costs for weighted average and FIFO. So there'll be 4 answers you'll have, 4 numbers. And I'll even give you the formulas. Notice, I'll go back to the other page. Notice I have the letters A, B, and C here, circled. So on weighted average, it's cost, units completed, total units completed, plus the percentage times the units that are in ending inventory. And conversion's the same formula. Units completed plus some percent times units in ending inventory. That's weighted average. In FIFO, it's the same thing, but you also have to subtract out what you're not going to be including the amount that's already been incurred. So you need to subtract out the costs that have already been incurred. Starting inventory times their percentage completed. Okay? So use this slide and the one before. I'm happy to, I can only have one slide up. Tell me which one you'd rather see. This one or this one? This one. Did you write down the formulae? Okay. Yes.
I'm kind of confused here as to what he was doing, but so is this percent of C for this, or percent for this? Oh,
so it would be B,
which is 44,000.
right, plus C, which is 3,000, times its percentage. Direct materials would be times 1.1, times 100.
Okay, so 3,000 times.
Times 1.
Yeah.
Okay.
Right. Like just going down to this one, for instance, conversion. So this would be 44,000 plus percentage. C for conversion. So it'd be 70 plus 3,000 times 70%.
Right.
Minus percent A minus conversion, 50% of 2.
Perfect. Okay. How many of you have it? Good. Gave you all the rubric, right? So it's easy. What are the equivalent units? Let's do weighted average here. I'll do them all. What are the equivalent units for direct materials using weighted average? 47,000. You take the 44,000 plus 3,000 times 100%. And how about for conversion for weighted average? 46.1. Okay, I think you guys have figured that out. 44,000 plus 3,000 times 70%. How about FIFO direct materials? 45. Same as it was for weighted average, but you subtract out the beginning work in process for direct materials. That leaves us to conversion. And what's the answer there? 45.1. Which is the 46.1 minus 1/2 of these units. So as we said, this more accurately describes the amount of work done this period. This is a little bit easier to calculate, and other aspects of the whole picture are easy to calculate off of it. Okay, so that's the baseline math that we'll need to do. Now let's do it with an example. The Naftel Toy Company. This is an example from the text. It's about 10 pages in the text we're going to consolidate. Okay, so Naftel is a toy company. They have two departments, molding and finishing. So it's a process because they just take some raw material, put it into a mold, press it. Then they probably have to kind of get rid of some rough edges in finishing and get it packaged and get it out of there. Molding places direct materials at the beginning of the process. The plastic is placed into the mold. Direct labor and overhead are incurred throughout the process, but they have different proportions. So we just made the project a little harder because we will not treat them as conversion costs. We'll treat them separately because their ratios are different. Some raw information. They're bringing 10,000 units in, and direct materials for the units brought in was $10,000, 100% complete. Direct labor was $1,060, and overhead was $1,620, 40% complete. That's given. So the total beginning inventory was $12,680. They started 40,000 new units in June. They completed a total of 44,000 units. The 40,000, the 10,000 that were in process, plus another 34,000, whatever, leaving 6,000 units at the end of the month for the next month. Those units are 100% complete for materials, because the materials are all added at the very beginning of the process. And as you can see, 50% complete for labor and 60% complete for overhead. And you can see the costs that were accrued during the month: $44,000 in materials. I guess it's $1 per unit. $22,440 in labor, and $43,600 in factory overhead. So their total costs was $110,040. Could think of these two numbers together because we need to somehow reconcile to these two numbers as we do our allocations. That's whatever there's 122,720, I guess, together. Keep those numbers in your mind. We need to reconcile that once we've.
That's 110,040.
The costs added in June. It does not include the costs that.
No, it doesn't make total cost.
Yeah, it's the total cost incurred. It's the 44,000 plus the 22,000 plus the 43,000 adds up to that. Yeah, it does not include the costs that were added in April, May, that are kind of coming into June because they were not disposed of in May. Okay, background information. These question marks we'll get to. I think we could figure out the numbers though if we tried. Okay, let's focus on the weighted average method. Step one, calculate your physical units. It's all given. We've said it already. You brought 10,000 in from the previous month. You started 40,000, so you need to account for 50,000. You know that you completed 44,000, and you have 6,000 that you're moving on to the next period. So 50 is equal to 50. That should always be the case. And now we do our calculation of equivalent units, using weighted average. We didn't do this math, so here we're going to do the math. We know we have 6,000 units going on to the next period. 100% of their direct materials, 50% of overhead, 6% of overhead and 50% of labor. So 50% of those 6,000 is 3,000 labor units, and 60% is 3,600 of your overhead. You add that to the units completed in the month, which we know is to be 44,000. And since they were completed, it was completed for all three drivers. So there were 50,000 equivalent units of materials, 47,000 equivalent units of labor, and 47,600 of overhead. using the exact same formulas we used for the little simple problem we did before this, right? This is that B plus percentage times C in weighted average. B plus, these are the percentage times C for each unit. So we now have our equivalent units of direct materials, our direct labor, and our factory overhead. Okay, determining the total cost for each cost element. This was given. That's at 12,680. This was given. These were both given on the original slide, the numbers. And so this is that 122,720. This slide's essentially been given to us. But the total cost includes the costs that were brought in from the previous period. So we're looking at this bottom line here in the weighted average method. Those are the total, that's the total cost we need to account for. Step 4. The cost per equivalent unit. Well, we know the cost, we know the equivalent units, pretty straightforward. Direct materials, direct labor, and overhead. We've calculated the total cost to add up that 122,720. From step 2, we calculated the equivalent units. You divide the total cost by the equivalent units by category, and you get a cost per equivalent unit by category. And from there, you can get your cost per total cost per equivalent unit, $2.53. Okay? Sure. I'll show you exactly. They were given to you. This is, you were able to get the total costs that you know. Okay? That's step 4. You're calculating the cost per equivalent unit. Step 5. Now you assign the costs. Remember that we had, well, first we have the units that were completed and transferred out, the 44,000 units at $2.53 a unit. That adds up to 111,320. And then you have the units that are in ending work in process. You know your number of equivalent units in ending work in process times the cost per unit that you calculated. So you put on a value for ending work in process. Just extend out those numbers, and as you would hope, it adds up to your 122,720. Now, if you go back to that original slide with the raw data, next period, these numbers, this 10,160 and this 1620, will be these numbers. That becomes the beginning work in process for the next period. Now, I think direct materials was at $1 in the previous period. So you see that the rate is recalculated each period here. So it's through this process that you assign costs to your units of production in a process environment using the weighted average method. Any questions on that before we go into the FIFO method? The 5 steps. Okay, let's do it. Step 1, exactly the same. No difference, FIFO to weighted average. Well, a lot of it's the same, but because step 2 is different, the numbers that derive all the way past it are different. And step 5 is different too. Step 5 is probably the one that makes it a little considers it more complicated. I don't think either of them are particularly complicated, but this is considered more complicated mathematically. So calculating your equivalent units. Remember, it was B plus C times its percentage minus A times its percentage. So we're subtracting out work that was performed in the previous month. That's what's happening there. So this was the same. But then we have to subtract out these 3 values that we didn't even bother to calculate under weighted average because they were not relevant. But they're relevant to us now. So our equivalent units now are some amount less than they are for weighted average, representing only the work done in this period. That's step 2, which you're now going to have different equivalent units to work with than you did under weighted average. Step 3, this is the exact same chart as we saw under weighted average, except since we're not considering the work done before in the previous period, we're also not going to consider the dollars associated with that work. So whereas for the weighted average method, we cared about the total costs to account for, in the FIFO method, we only care about the costs added this month because we only care about the work done this month. So we'll ignore these for the moment and focus on this line. So calculating the cost per equivalent unit in FIFO. We've got our costs from step 3. We have our equivalent units from step 2. Each of them different than they were for the weighted average method. And therefore we have a different cost per equivalent unit to calculate. In this case, I think it was $2.53 for weighted average. Now it's $2.61 per equivalent unit. And this really reflects the work that's done in this period and only this period. That's the big difference. So the math's the same, just using different bases for doing the math. Notice we left out this 680, but we want to show that it still has to add up to the same amount. We're just not including that. Okay, step 5. Now we get to assign some costs. This is where it gets a little bit more complicated. We want to assign costs to different categories. You want to assign the costs to the units that began, that were in beginning inventory. You want to assign costs to that units that we started and completed, and then separately assign costs that were going into next period. You have your costs based upon this is the work in process inventory that started the period. I'm sorry. So you had 10,000 units that you had in work in process to start the period. This is the cost to finish those units. I misspoke. So I forget the percentage completions. We had 70 and 60%, I think. Or they were 30. I'm sorry, they were 30% complete and 40% complete. This is the cost for the other 70% to finish the direct labor and 60% to finish the overhead. This is the cost to finish those units. Now I don't have anything for direct materials. Why? They were 100% complete last period. So there's no new costs for direct materials for those units. So your cost to finish those units this period is $22,250. Plus they had a cost from last period of $12,680. So this brings it all together. You had the cost from last period, which we just carried through just so we can add it up at the end to the total. You have the costs added to those units to complete them. But there's the cost to start and complete the units. There were 34,000 units like that at $2.61 a unit. That's the cost to complete those units, start and complete those units. And then you have the units that are in ending inventory for next period. And you have to account for those. You have the same rate times, there were 6,000 units in that category, and the percentage complete were 50% and 60%, I think, 50 and 60%. So this is the cost to get that far. And so you add up 1268, 22,000, 8870, 740, and plus these costs here, and that gets you to your 122,720. So you see, you have to categorize your costs into the units that you brought in and finished, the units you started and finished this period, and then the units that remain in work in process until the next period.
That's just so you know what your balance sheet looks like?
This is so you know what your costs per unit are. You had a budget per unit probably, and how are you doing? How are you doing this month? This is your way to judge how efficient you were in the month. Yes, in this example, definitely. You would finish that first, right? Because it's on an assembly line. In some way, it's on an assembly line. Maybe it's in the drying kiln at the end of the period or something. I don't know this specific process. So that's going to be finished before the work behind it gets finished. Now you can have more complicated problems where, it doesn't get wine making. It doesn't get completed. It just gets further along the process. So this period, you had 70% of direct labor left, but you only use up 20% of it because there's another period before it's done. So calculations are similar but not the same. Because you need to know how many you started and you have to know how many are in each of these categories, right? You need to know how many physical units you have in ending work in process, because then you need to be able to calculate the equivalent units from the physical units. You need the physical units to get you need the physical units by category to get your equivalent units. Well, maybe it's already there and you don't need to calculate it, but you do need to know it, and you need to organize it. And it may need, in a problem we create, it may need to be calculated like our sample problems. But you're right, you can figure that out. How many of you feel comfortable with this? Marginally? Marginally. You have to do it, right? I don't want to spend the class time doing it, so I suggest finding the homework problem to do this. And if you're struggling with the homework, email me. I need to make a judgment whether it's 70% of the chance class that's struggling with the homework, then we'll do it in class. And if it's a few of you, maybe we can do, email me back and forth. Maybe I can work you through it. So I don't like to do homework in class just because I find there are a few people who are very intense on it and others who couldn't care less and are bored and feel like I'm wasting their time.
Are the answers
I posted all the answers, yeah. I don't post them immediately. I think I posted these to be available like next Monday. Give you a chance to work it and struggle, and rather than just go to the answer and not struggle. If you don't struggle through it, then you're not really learning. Questions? Okay, so how do you choose between weighted average and FIFO? Based upon your faces, I think you all felt that weighted average is a little bit easier than FIFO, but not much. It's just once you get the rhythm of it, they're not that dramatically different. So weighted average is easier. If you have small work in process inventory, for the most part, you finish most of your work by the end and the work width is small, then don't invest in FIFO when it's not really going to be particular material. Also, if your prices from month to month are stable of your materials and your labor, then you're not really going to see much of a difference between FIFO and weighted average. As we said, FIFO offers better control at somewhat of a cost, but the cost is worth it if you have costs. If oil is a major input and you want to really understand your costs from period to period, then you might want to consider using the FIFO method to really see those fluctuations more clearly, because the weighted average smooths it out from period to period. So there's no one right answer. It's each company difference. And the production cost report, which there is an example in the text. If I tried to put that example on the screen, it would be numbers would be so small it would render it completely useless. Brings those 5 steps together into a single document. And that is the output by department, by period. And so it just brings everything together, and you get to see it. Okay, multi-departments. So our example with winemaking had two departments, bottling and winemaking. So you have these goods that are transferred from one department to the next. The wine is transferred. The easiest way to think about it is they are direct materials, 100% going in at the beginning of the process. So the goods that are being transferred from the winemaking department become an input to the bottling department 100% on day one in the period. You might be able to make a case where some are transferred in the middle of the period. You have to understand the process in particular, but the default is they all come in and they become, it's just flowing through the next department. So here it is visually with you have production department and testing department. The only direct materials going into the testing department at the beginning are the results from the production department. What's going on here? What's that? All right. Material costs. What's that? Direct materials. Maybe you failed the test and they have to swap in a new part or something to make it ready to go. So at the end of the testing cycle, you fix the problem and get it ready for production. Okay, calculating the equivalent units when you have transferring costs. It's just another line item with 100% completed at the beginning of the process. Okay, nothing tricky here. Another line item to calculate your calculation, to complicate your calculations. That. Spoilage in process costing. There are two ways to handle spoilage. One way is recommended and the other way is not. You do a separate equivalent unit computation that includes the spoiled goods, and then you allocate the cost of the spoiled goods to the good units in much the same way we talked about doing it for job costing. The second is to omit the spoiled units in the costs, and then at the end of the process average it over units produced and ending working process. The point is, if they're normal, they ought to be included in the costs. You should, the cost of doing business is that you'll have some spoilage. If you have abnormal spoilage, is you figure out the cost of those abnormally spoiled units using your cost per unit that you've calculated already, up to the point where it was figured out that those are spoiled, and then once again you want to report them separately so everyone sees them, and you can take the correct remedial action.